Alright, part 3 of the entire video, and this has nothing to do with calculus anymore, but anyway, I'm going to discuss this in detail. So these are the data that we need to determine from our given points, the points to be plotted on the graph. So it's not simply drawing our RCS. That is not as simple as that. If we have a limited space, just like in this case, we only have to determine them. We need to consider them. So what do you want, or where do you want to start? The vertical or the horizontal axis? If you say vertical axis, then look at the values of x. Where do we place our vertical axis? Would it be at the middle? The answer is yes. Why? Because of these values of the x coordinate. So since it's balanced, the positive and the negative value or values of x, then the vertical axis would be placed at the middle. Alright? So when the positive value is greater than the negative value, then our y-axis will be a little to the left or to the left. But when the negative value is greater than the positive value, then it is oriented to the right. But since they're equal in terms of the value only, regardless of the sign, then the vertical axis will be placed at the middle. Alright, so that is the mathematical interpretation of those statements. So let us now analyze the other two characteristics. It will determine the placement of our horizontal axis. Would it be a little above or a little below? Since they are not equal in terms of the magnitude, regardless of the sign, the positive value is greater than the negative value. So our horizontal axis will be located a little below. A little below. It's not going to be at the middle anymore. Okay, after the placement of our the two axes, then how shall we calibrate our reference axis? We only have to determine the highest coordinate value. It may be from the y or from the x coordinates. In this case, it is the y coordinate, which is 4. So we will calibrate first the positive y axis. That's it. You place 4 right there. That's our maximum value for the positive y-axis, and then the rest will follow. So that will determine already our calibration, the length of 1 unit for the reference axis. It will be both for the y and the x-axis. So there you have it, ladies and gentlemen, and now we're ready to plot the points. Okay, I have plotted the red 2 points, the easiest among which is of course A, which is a y-intercept. So as you can see, at point A, the graph of the function will cross the y-axis. That's why it's called the y-intercept. Then point B, right there, is just a minimum point, and obviously somehow it's going to be minimum because it is located at the bottom of our space or our coordinate system. Then for point C, alright, so that's it. That's the location of point C. So point A is really the highest, and at the same time is the y-intercept, so it's a local maximum, while points B and C are local minimum, and after which we will determine the rest of the characteristic of the graph using this generalization we had a while ago. So let's now try to sketch the graph. So with regards to the region within the 3 known points, that's how approximately that is how the graph will look. So beyond that, then we will apply this. So as we increase x further to the right, what happens? Y also increases. That means that the direction of y, of course, is up, because as you go up, y becomes more and more positive. Alright? And it will never look back again. So that's it. That is how it looks like. As x increases, y increases positively. And on the other hand, after or before point C, as x becomes more and more negative, our y becomes more and more positive. So that's the approximate sketch of the graph of our function. And finally, yeah, the name, the label. The label. Don't ever assume it must have a label. Alright? So ladies and gentlemen, that is approximately the sketch of the given function. Thank you.